Alright, for this short video I wanted to show an interesting way to use the volume builder in the vector mode. This is a pretty deep topic, but so it might end up being a few videos, but well, let's just get started. So first you can see when I drop this mesh in, we get a bunch of vectors pointing out away along the normals from the mesh. Which is interesting and cool in itself. But what can we do with those vectors? Well, we can take a matrix, maybe let's scatter it on the object, and then we could use a target effector set to field direction, and you can use this volume builder, the volume object, with a direction. We can also turn on repel, and this will push these out away from the mesh or into the mesh. Now, that in itself is not all that amazing. You can kind of already do that because the clones align themselves to the mesh already. But what's interesting is that you can change these vectors. You can modify them, right? So in the volume builder, you could say, I want to rotate these vectors. Let's rotate them 90 degrees on the x. And now, instead of that being pushed directly out on the normal, they're being pushed kind of along the surface in sort of a roundabout kind of way. So that's cool, but it's not that great. I mean, the rotation here is an interesting trick, but can we do better? Let's take a look. So let's try using a linear field. Now, if we drag the linear field into this vector volume, you'll notice a couple things. One, by default, the creation space is box, so it creates this, only creates the vector voxel values here in this box. Even if I move the linear field around, the box is defined by these coordinates down here. But we can switch the creation space to objects below, in which case it'll use the already active voxels from the below objects. Now, something that I think it's important to note here is that, well, two things. One, the fall off is not visible really in these vectors. The vectors don't appear to be getting shorter in size, but we can see that there is a fall off here. So that's important to note. Volume builder in vector mode does not show the magnitude of the vectors. It only shows the direction that they're pointed. The other thing to note is that pretty much all fields that I've run across by default have their direction inverted. Sometimes that's useful, sometimes it's not. So for a linear field, it kind of makes sense that the direction of that arrow is the direction they'd be pushed, right? And then if you don't want this fall-off behavior for the linear field, what we can do is we can just raise the minimum so that it's the same as the maximum, 100%. And now it's a constant magnitude. It's always pushing the same amount, and we can just control the direction that it's being pushed in, right? Okay, well, so how is this useful? Got our linear field, it's pushing them off that way. One of my favorite things about the vector volumes is this mode here, cross. So this takes a cross product. This is all maths here, but the cross product essentially takes the vectors that exist below and the vectors that this is generating, and it takes the cross product of them. So this is what you get. That looks an awful lot like that rotation, that 90-degree rotation, and it sort of is. But we can also interactively move this linear field and change the direction of that rotation. Right? So if I point this straight up, now it's sort of orbiting around them. We can take our target and we can see how it kind of spins around them for a moment there. So this is interesting, but you know what? The target effector, let's get rid of it. It's not doing such a great job. Let's try using particles. We're going to use thinking particles, which is something I haven't heard anyone say in quite some time. So for thinking particles, we need an espresso tag. We're going to add a ppass node. Particle pass. Pass is all the particles in this group, the all group, and we can look at the thinking particle settings to get a sense of, okay, here I've created a subgroup that is a member of the all group. So the all group would, if I added another subgroup here, cool group. All the folks in subgroup just wish they were in cool group. ppass all will send all of the particles, whether they belong to subgroup, cool group, or some other group, to the next nodes down the line. It's essentially an iterator. So you'll see the output here as I mouse over is a particle. And whatever operators I put out here will act on each particle that comes out of this ppass, which is all the particles in this case. So I'll make a new node, thinking particles, dynamic force object. So we're going to apply forces. Well, where are we going to get our forces? The volume builder doesn't make any forces. What we need is a field force. And if we drag our volume builder into the field force as a volume object, it will provide forces. Ta-da! The force object we want to use is the field force. So now if we play, right, I mean, that's behaving a lot like that target effector if we kind of increase the, like it kind of gets away from us, doesn't it? And that's because the field force currently is set to add to velocity. If I set it to set absolute velocity and then increase the strength a little bit, we can see that these are now sort of orbiting, rotating around them. Whenever they hit the edge where there's no more values, vector values, they'll kind of stop. So the way we can affect that is in the volume builder. You could increase the voxel size, which will give us less data, but it'll be spread out more, get a little farther away. But you can also, on the mesh, increase the exterior voxel range. So this is the number of voxels that are each 10 centimeters that it builds outside of the mesh. And then let's add some interior as well, I suppose. Right, so that's something, you know. I don't have to, they're moving by themselves. Hey, cool. But now let's think about, okay, what would happen? How could we make them sort of randomly move? Well, let's try using a random field. We're going to drop this into our volume builder. Now again, this has the same issue as creation spaces box. We're going to do objects below. We're going to increase the scale of this random until we can kind of see the structure of it. And keep in mind right now this is set to normal, so it's just generating. What we'll actually see here is that they end up getting kind of stuck in little pockets. And you also see the jittering there. I'm going to change the sample mode from nearest to linear. And that should help with some of the jittering. That essentially changes how it reads the value. You could also try quadratic, just a smoother way to interpolate between the voxel values. So they're kind of clumping up, but that's not a very cool motion. Let's try our old friend cross. Okay, all right. It looks like, let's increase this a bit. Yeah, it looks like they're kind of moving along the surface, huh? And what's essentially happening is that they're rotating along the surface, but the rotation that they're using along that surface is changing in space because of the random field. Now, what else can we do? Okay, on the random field, let's add some animation speed. And you know what, to really appreciate this, let's add some more time on our timeline. It's still, some of these are not moving very quickly. What we can do is we can the volume builder, you could apply a vector normalize at the top. And what that's going to do is make the magnitude the same for all of these vectors, which in this case is a bit much. So maybe we'll skip that. But another thing you might notice is when this is moving faster, if I increase this, they actually do sort of slowly migrate away from the surface, or in some cases quickly migrate away from the surface. One way we can counteract that is by adding another copy of the mesh here. And you'll notice now it's shooting out. If we set this to add, now they're still moving, but they're also shooting out. Or if we set it to subtract, now it's pulling them in to the center. Now, that's too strong, so what we can do is we can scale those vectors. I could set this to add or subtract. I'm actually going to set it to add, and then on the scale I'm going to do a small negative amount. So what that should do is keep things more or less on the surface, but it looks like it may be pushing them into the center, and what that's telling me is I probably need to reduce my voxel size. Because what's happening is there's places where I'm not getting data inside the mesh. If I turn the visibility off here, the nature of the SDF, the sign distance field that is being built by these meshes, is that there's values inside, essentially. But we need to make sure that we're filling that inside with values so that they all point toward the when we invert it, they all point toward the surface. So let's turn these back on. Turn these back on. And then I think I am going to normalize this, and then I'm going to reduce the strength a bit. All right. Let's turn our volume builder off. Let's add a tracer. And we could probably trace the matrix. Should work fine, I think. And let's turn these people off and see what we have here. Let's turn the matrix visibility off. Yeah, you could also trace. The tracer does accept thinking particle groups, so you could drag this all in here, and then it would trace the particles. But in this case, there's no difference between the matrix and the particles, essentially. So this is working. This is looking interesting. I think something that could help us, and this is not directly related to the volume builder, this applies in other situations as well, but something that could help us is getting a more even distribution of these matrices across the surface. Now, maybe the vertex is pretty evenly distributed, but you know what? I think there's a few too many of them. So what I'm going to do is I'm going to stick with surface, and I'm going to increase this to something, say like 3,000, which is still quite a few. And then I'm going to use the push apart effector well, I'm not actually going to push anything apart. Instead of push apart, what I'm going to use is I'm going to hide. And since we're hiding and not pushing apart, we can do with much fewer iterations. So I'm just going to do one iteration. And for radius, let's say 3 centimeters. And when I apply this to the matrix, what it's essentially going to do is it's going to say, okay, look around the matrix, this matrix, and if there's any others within 3 centimeters, make it invisible, right? So that gives us far fewer matrices, but if you look, we still have the same number of thinking particles. I think that's okay in this case because we're not tracing all of the particles, we're just tracing the matrices. But just to be super complete, on the object here, you can say particle priority. Does the particle get born before the effectors take effect or after? So I'm going to say after, and now the particles will correspond with the matrices. And so that can give us a nice quick view of sort of where these particles are, how they're spread out, right? I can increase the count here. This count, so it still has to generate all these. If you go too high here, danger. It is still generating all of these, and then it's hiding most of them with the push-apart effector. So if you take the count up too high, the push-apart effector can slow down, especially with lower radiuses. As this radius is higher, it's more likely that it's going to quickly find and remove clones, right, or matrices. So I'm gonna go back here and I'm gonna reduce this down a bit, say 5,000. And then on the push apart, we can use this to sort of control the density. How many particles do we want? How many matrices do we want? So if I set this to 0, that's our source. If I set it to 1, I'm kind of eliminating a fair amount of them. And the higher I go, the more evenly distributed, well, the higher I go with the matrix quantity and the radius here, the more evenly distributed these things should end up being. But let's see what our tracer looks like now if I disable the people. It's nice. It's maybe a little too dense, so in that case, I'm going to just raise the radius a little bit. There we go. Looks like they're still kind of advecting in toward the middle some. So we could try using a slightly lower scale here, maybe. Again, this folder here, what it's essentially trying to do is to try and apply some force to push the particles so that they remain on the surface. Everything below it is creating this sort of curl noise on the surface advection craziness. You can use different noise types as well. Let me see. You get slightly different results depending on your noise type. So you can play with that. Perlin tends to be a good one, though. Anything with too much detail, things are going to be a bit jittery. Yeah.